Scientists have managed to discover the most massive collision and merger of two black holes using gravitational waves. They successfully identified the waves resulting from the violent collision of two colossal black holes that collided far beyond the edges of the Milky Way galaxy. This gravitational wave, named G231,123, marks the heaviest black hole merger known to date, identified through the collaboration of the LIGO-virgo-kagra detectors. Each of the two black holes had more than 100 times the mass of the Sun and had been orbiting each other for a long time before finally colliding to form a significantly larger black hole. This event occurred about 10 billion light-years away from Earth. The merger of the two black holes resulted in the birth of a new black hole with a mass equivalent to 225 times that of the Sun. The results of this discovery were presented at the Edward Amaldi Conference on Gravitational Waves in Glasgow, Scotland. The identified merger is the most massive black hole merger ever recorded by gravitational wave detectors, compelling physicists to reconsider models of the formation of these massive objects. The collision signal was detected by hypersensitive detectors capable of recording spacetime vibrations that are thousands of times smaller than the diameter of a proton. Most black holes form when massive stars exhaust their nuclear fuel at the end of their lives and collapse. These incredibly dense objects warp spacetime so much that an event horizon is created, a boundary from which even light cannot escape. The LIGO-virgo-kagra collaboration has identified several cosmic mergers since the discovery of the first signal, which led to a Nobel Prize. Initial mergers included the collision of two black holes or two neutron stars. In 2021, this collaboration confirmed the identification of two separate hybrid mergers between a black hole and a neutron star. Previously, the heaviest black hole merger was related to the GW 190,521 event identified in 2020, which produced a black hole with an intermediate mass of about 140 times that of the Sun. However, during the fourth observing run, the GW 231,123 event turned out to be much more massive. Analysis of this signal revealed that the colliding black holes had masses of 103 and 137 times that of the Sun, respectively. Announcing this discovery took some time because these objects were spinning at incredibly high speeds, near the limits set by general relativity, making the signal analysis considerably more difficult. This new discovery is also significant as it contradicts current theories about star evolution. The parent black holes are so massive that they can hardly be attributed to supernova explosions. Just like the previous event, G190,521, this new event, G231,123, is likely an example of hierarchical merging, that is, each of these black holes was itself the result of a previous merger before coming together and merging again. Before the construction of gravitational wave detectors in the 1990s, scientists could only observe the universe through electromagnetic radiation, such as visible light, infrared, and radio waves. However, gravitational wave observatories have provided a completely new perspective on the cosmos, allowing the observation of events that were previously hidden. What happens during black hole mergers? Black hole mergers are among the most powerful and mysterious cosmic events. They are surprising yet one of the most turbulent and intense events in the universe. But exactly what happens in this process? The story begins with two black holes that orbit each other in long, slow ellipses from a great distance. These black holes likely originate from a pair of binary stars or may have randomly encountered each other in the depths of interstellar space. In any case, to merge, these two masses must come closer together, meaning they must lose a significant amount of orbital energy. The first step in robbing the system of energy occurs through the interaction of the black hole with its environment. Black holes are not alone, they always have rings of gas and dust and sometimes even larger objects like planets or stars orbiting them. All these objects interact gravitationally with the black hole, and occasionally, they fall into it, never to be seen again. Sometimes their initial speed simply increases, taking away some of the black hole's orbital energy. When black holes get close enough to each other, a different process begins. In this situation, the black holes spiral around one another, distorting space-time and creating gravitational waves that emanate from them like ripples on a pond. However, these gravitational waves are incredibly weak and only seriously pull in energy when the black holes are in very close proximity to one another.